Hello and welcome to another Edexcel iGCSE Computer Science past paper question. This is the 2021 paper, 2 hours long, and you'll get this paper printed off in an exam. You must have the pseudocode command set to go with it. That will be in the back of the paper. To be able to answer this paper, you need a specific command set, and Edexcel provides you with that for your exam, so make sure you get something. Paper is 2 hours long and the total marks are out of 80. You must use a black pen to complete it and you must try and answer all questions. There is no calculator allowed. So let's jump in and have a look at question 1. So question 1a. Binary digits, bits, are grouped together to represent different types of data. Hexadecimal notation is sometimes used to represent patterns of binary digits. Identify one reason why programmers use hexadecimal notation. The only answer is B. It's easier for humans to read. That's why we use hexadecimal. It's easier for humans to read. So make sure you put an X in the correct column. B. Convert the bit pattern 01011010 to hexadecimal. Now, when given a question like this, is 2 marks, what you need to do is remember that you've got 2 4-bit nibbles there. 0101 is a 4-bit nibble, 1010 is a 4-bit nibble. Now, you can write this down. What I'm just going to do is quickly just talk you through this. So to do my conversion, I begin by creating my place values there. 8421, 8421. It's 8421, 8421 because we're talking about 2 4-bit nibbles. So then what I need to do is place the 1s and 0s into the bit pattern. So now we just simply add them up. 4 plus 1 is 5, 8 plus 2 is 10. So my first digit is 5, and my next digit is 10. Now 10 isn't 10 in hexadecimal, it's going to be A. So my answer is going to be 5A. Final answer is 5A. C. Identify the number of binary patterns that can be represented by 8 bits. So 8 bits we can represent 256. D. Complete the table by adding these 2 8-bit binary integers. Now, this is really simple to do. Just need to remember the rules. I'm not going to write the rules down because I've been through them in many videos before, but 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 1, 0, so the 1 is going to be carried. 1 plus 1 plus 1 is 1, 1. And again, with a carry. So we'll go through this table applying the rules. So 0 plus 1 is 1. 1 plus 1 is 1, 0, and I'm going to carry the 1. So 1 plus 0 is 1. 0 plus 0 is 0. So 1 plus 1 is 1, 0, and we're carrying the 1. So now because we carried the 1, we've got 3 1s, and that's going to be 1, 1 with a 1 to carry into the next column to the left. So now I've got 1 plus 0, which is 1, and finally 0 plus 0, which is 0. So we'll just look at what we've done. Now the top number there is 50, and the bottom number is 51. So 50 plus 51 should give me 101, and if I look at the answer that I've got, 64 plus 32, that's 96, plus 4, that's 100, plus 1, that's 101, so that answer is correct. So move on to E. Give the result of performing a logical left shift 1 place on the binary integer 0, 1, 0, 0. So what I'm essentially doing when I perform a logical left shift is I'm going to be doubling the number. So 0, 1, 0, 0, that is 4, so I should end up with 8. So just 1 shift to the left, and that gives me 1, 0, 0, 0. Now just be careful with a question like this that you don't kind of write down what's actually happening. That's not what you're asked to do that. You're just asked to give the result. You're just asked to actually do the left shift, not describe what's happening. So don't bother describing what's happening. Just do the shift. F. Give the number of bits per character used by standard ASCII is, of course, 7 bits. And that gives us up to 128 characters. G. Figure 1 shows a black and white bitmap image. Pixels are in row 5, represented by the binary pattern there. State what is meant by the term pixel. Pixel is the smallest addressable block of colour. 2. Construct an expression to show the number of pixels in the image. Well, there's 8 by 9, so the expression is 8 times 9. Now, you don't need to write the answer down for that, okay? This is non-calculated. You probably know your 8 times table anyway, that's 72, but we don't need to write that down. So that's the number of pixels we've got in the image there. And the last one of question 1, the image is changed so that any pixel can be one of 16 different colours. Take the minimum number of bits, minimum, note the word minimum there, that will be needed to represent 1 pixel. So if we now got 16 colours, we now need 4 bits. And that completes question 1 for a total of 11 marks. Question 2. Many organisations use networks. One reason for networking computers is to share access to the internet. Give one other reason for connecting computers in a local area network. Now, I've already got connect to the internet, so this one is to share peripheral devices, printers. B. State the purpose of network protocols. So network protocols provide the rules of communication between network devices. Protocols is rules, so this is rules of communication in a network. C. Data is transmitted in packets. Identify the layer of the TCP/IP model that would allow the file transfer protocol FTP. The answer is A. Application layer. 2. Give one task carried out by the network layer. The network layer adds the source destination IP address. D. Complete the table by adding a tick to match each item to its name. So https www.pearson.com is the URL. The number starting 216 is the IP address, and Pearson.com is the domain name. E. Figure 2 shows a network topology. State the name of this network topology. This is, of course, the bus network because we can see it's a straight line, kind of looks like a bus line. You've got terminators either end. State one benefit from using this topology. And really the main benefit is the cost, lower cost as fewer cables are needed. 3. State one drawback of using this network topology. Well, when data is sent down the line, every other workstation can see the data. So a drawback is every workstation can see the data. F. Files may be compressed using lossless or lossy algorithms. Music files are distributed over the internet. Give 2 reasons why lossy compression is used when distributing music files over the internet. Lossy compression is when data is lost, and it's lost permanently, and as a backup was saved of the original file. So once you go through lossy compression, you lose all that extra data. The reason why you would go through that is because you make the file smaller, which is going to reduce storage requirements and also reduce the bandwidth needed. So put for my answer there, reduce the bandwidth needed to send data, reduce the storage space needed to store the file. 2. Identify which one of these file formats uses lossy compression is, of course, JPEG. It isn't A because it's not compressed. It isn't B because we don't want a lossy compression for a document. We'd lose half the file. That would make the document pretty much unreadable. And it isn't D because it uses lossless compression. So the answer is C. 3. Here's a string of data. Give the result of compressing the string using run length encoding algorithm. Now, I have done videos on run length encoding. Now, run length encoding is where you count the amount of letters there and you write down the amount. So we look at that, we can see 3 C's, 3 W's, 2 C's, etc. So we just simply write that down, and that's run length encoding. So our answer is 3 C's, 3 W's, 2 C's, 6 W's, and 3 C's. G. A video file is to be transmitted over the internet. The network transmission speed is 54 megabits per second. The file size is 6 gigabytes. Construct an expression to show how the transmission time in seconds is calculated. You do not need to do the calculation. So what we need to do is work out the file size. And we need to work out that in bits. Then we need to work out how many bits per second and divide the file size by bits per second to give us the answer. Now the file size must be noted that it is in gigabytes, so it is 1000. It's 6 times 1000 to the power of 3, because it's gigabytes. Remember, kilobytes, megabytes, gigabytes, that's 3. And then times that by 8 to give us that in bits. There's 8 bits in a byte. So we now need to divide that by the network transmission speed, also in bits per second. So we would need that in bits per second. So it's 54 megabits per second. So it's 54 multiplied by 1,000 to the power of 2. So you could write 1,000 times 1,000 or 1,000 to the power of 2. And that is our expression there for 4 marks. And that completes question 2 for a total of 18 marks. Question 3. Zakir wants to buy a new laptop. A. He knows that a laptop has both hardware and software. Explain why the laptop needs both hardware and software. So hardware gives both input and output devices to interact with the device. Software is a set of instructions that controls the hardware. B. Zakir needs to choose between a solid-state drive and a hard disk drive. Give 2 reasons other than cost and capacity why Zakir may choose a solid-state drive rather than hard disk. There's loads of reasons. Solid-state drives are far superior to traditional magnetic hard disk drives. So my first reason is it's much faster to access data, and my second reason is less power is needed, which gives me a longer battery life. Less power is needed because it doesn't have any moving components which are going to use power to get it up to speed and keep it at 7,200 RPM. The solid-state drive has none of that, so it's going to use less battery. 2. Solid-state drives store data on flash memory, which is similar to RAM. Explain one difference between flash memory and RAM. Well, flash memory is non-volatile, whereas RAM is volatile. So when power is no longer going to RAM, it will lose whatever's stored on it. So when you switch your computer off, whatever's stored temporarily in RAM disappears. Now, I just kept it really simple. Flash memory is non-volatile, whereas RAM is volatile. C. One of the laptops has 4 megabytes, not megabytes, of cache memory. Explain the purpose of cache memory. Cache memory is closer to the CPU than RAM, and it stores commonly used instructions. So it's going to speed up processing because it puts those commonly used instructions in cache memory. It's closer to the CPU, so it can access them a lot more quickly. D. Zakir uses many devices. Complete the table by adding a tick to show whether the device is input, output, or both. So a headset is both, because you've got the headphones bit and you've also got the mic. Mouse, just simply input. Printer is output. And finally, the touchscreen is actually both. Some people make the mistake of just saying it's an output, but there's also, because it's a touchscreen, there's some interactivity there, so that makes it both. And our final question for number 3, Zakir needs to protect his laptops against malware. Give 2 types of anti-malware software he could install. We're talking antivirus and perhaps a firewall. That's what I put there. And that completes question 3 for a total of 12 marks. Question 4. Scientists often use models and simulations. Give 1 reason other than cost why scientists use simulations. It's to predict model outcomes. So with simulations, we can look at what happens with different possible scenarios and predict their outcomes. B. Explain 1 reason why a simulation might require a powerful processor. So my first answer is that a simulation may involve a large number of calculations. That would be 1 mark. And a simulation may output complex graphics. So for both of those, we need powerful processors. C. 3 marks. A scientist uses Boolean logic in programs. Complete the table to show the results of each operation. So we've got R, S, W there, inputs. We've got not S, R and W, not S or R and W. Now, you get marks per column. So we start with doing not S, then we're going to do R and W, etc. We get each column right, then we move on to the next one. You do not do it row by row, because you're going to lose track of where you are, and also that's not how you get marks. You might get stuck halfway through and get no marks. So do this, exam tip here, do this by column. So not S means the opposite of what S is. So zeros become 1. So we can see in the first row there, S is 0, so that not S needs to become a 1. So that is the first column completed. 1, 1, 0, 0, 1, 1, 0, 0. So zeros become 1s and 1s become 0s. Now we've got R and W. Now in order for that to be a 1, we need both R and W to also be a 1. So with 0 and 0, that's obviously going to be a 0 in the first row. So the first row is 0. And the next one is 0, because although W is a 1, R is the 0, so that also needs to be a 0. Now that's the same for the next 4 rows, but if we look at the third from the bottom there, which is actually the 6th row, R is 1 and W is 1, so R and W is now a 1. So that now completes that column, and as I said, do it column by column. I've now got myself 2 marks. So the next one is a little bit more complicated, so we need not S to be a 1, or R and W to be a 1, so that's either. So as long as not S is a 1, or R and W is a 1, then not S or R and W will also be a 1. See, for the first one there, not S is a 1, so not S or R and W can be 1, even though R and W is 0. And that will be the same for the next row as well. The next row will be 0 because both of them are 0, as will the next row. Now in the 6th row, not S is 1 and R and W is 1. Now, because this isn't an exclusive OR, this is just an OR gate, then that will also be 1. And that completes our logic table there for 3 marks. So remember, do it column by column, not row by row. And then you're more likely to get marks, even if you get part of it wrong. D. Von Neumann developed the stored program concept. Describe the stored program concept. So in the stored program concept, instructions and data are stored in main memory. Instructions and data are fetched, decoded and executed by the CPU. 2. The fetch, decode, execute cycle is a cycle the central processing unit follows in order to process instructions. Name 2 registers used in the cycle. There's quite a few I could have here, but I'm going to name 2. So I put for my answer the program counter, PC, and memory address register, MAR. 3. Describe the role of the address bus and the data bus during the fetch part of the cycle. So what happens is the address of the instructions carried on the address bus to main memory, so where the instruction is that we need, that we're going to operate on, the processor is going to operate on, and then the contents of that address carried back to the CPU on the address bus, and that's 2 marks. Now, number 4, the final question of question 4, complete the table to show the effect on a computer system of increasing the width of a bus. So increasing the width of a bus effect, increasing the width of the address bus and the data bus, and the effect. So increasing the width of the data bus increases the number of bits that can be transferred at one time, and that will be 1 mark. And increasing the width of the address bus increases the number of memory addresses. And that completes question 4 for 14 marks. Question 5. Isaac is a program developer. Figure 3 shows an algorithm Isaac has written. So we've got start, we've got numbers there, we've got an array where values have been assigned to each element in that array, 10, 6, 1, 9, 3. Count equals 0, length equals 4, midpoint equals 2, temp equals 0. And then we move into a decision, count less than midpoint, yes, etc. And then what we're asked to do is to trace that through. So we'll trace this through now, and what we'll do is I'll keep going back to the flowchart and then referring to the flowchart and then filling this in. So that's what you'd do in your exam. You'd look at the flowchart and then complete this. Now, this is a little tricky, this question. It is 5 marks. It's a little bit tricky. It can stump people with a few points. So we'll go through this very, very carefully now. So you can see there you've got the array and then all the values have been initialized. You've got count equals 0, length, midpoint, temp there. So we can start by going up and we're straight into this decision there. Is count less than midpoint? Okay, well, midpoint is 2 and count is 0, so that's going to be true. So then that's okay. So now we go into temp equals numbers count. Okay, so temp here this is what we need to complete now. So numbers count, okay, 0, so that's then 10. 10 is placed in temp. Okay, let's go and look at the next bit. Numbers count equals number length minus count. So numbers count, okay, so that's here, 0, count is 0, so that's here, is equal to numbers length minus count, okay. So numbers length 4 minus count, so that is equal to element 4. So length minus count is 4, 4 minus 0 is 4, so we're looking at element 4 of the array, so 3 gets placed in here. So I'll place 3 in element 0 of the array. Numbers length minus count is equal to temp, okay, so length minus count, so that's this element here, 4, is equal to temp. So element 4 is equal to 10 because in temp is 10 and that's going to be placed there. Count equals count plus 1. So now I add 1 to the count. So now I place 1 in the count. Now I'm going to loop again because count is less than midpoint. Midpoint is 2. So yes, that's still true. Temp equals numbers count. So temp now, we scroll down, it's going to be equal to 6 because numbers count is 1, so 6 is going to now go in temp. So for some of you now, you might be able to sort of guess what's going to happen with this, what's happening, what actually is going on with this algorithm. Numbers count equals number length minus count. So length is 4, minus 1 is 3. So numbers count, okay, which is 1, is equal to what's in 3. So that is going to be a 9 that goes in there, okay? And I can guess the next bit, numbers length minus count becomes equal to temp. So temp is 6 and temp will go in element 3. So 6 will go in element 3. And then count equals count plus 1. So now count equals 2. And then count, if we look just check back at that decision there, count is less than midpoint, no, stop. So now we can stop. So you might be able to guess what's happened there. We can see that the numbers in the array, the elements of the array have been flipped around. And we've done that by using this temp here to store the value being rotated, the value being moved at the time. So give the purpose of the algorithm to reverse the contents of the array. Explain why variable temp is needed. Temp is needed to store the variable being swapped at the time so that it's not lost. Figure 4 shows an algorithm Isaac has written using pseudocode. The algorithm should display the average of the numbers that have been input. Now, Isaac uses these inputs there, 2, 3, 5, 2, negative 1 to test the algorithm. He discovers an error. The average is 2.75 expected result, but he gets 2.2. So what has actually happened there? So negative 1 should end the program, and it does, but it also adds in negative 1 as well to give a slightly lower average. So the problem is this negative 1, which has been included in the addition but not been added to the count. So when we add the negative 1, then we get the result 2.2. So perhaps he needed to change that to something else to quit the program rather than negative 1 rather than a number. So give the number of the line that contains the error. So if we look back at the program there, you can see that the error here is in line 10. And obviously when you're given a question like that to find the error in a program, then you can see that the next question is going to be correct the error. So I'm going to set average to total plus 1 divided by count minus 1. So that will correct the error. You could also have line 3 where you set count to minus 1 as well. Could also be an answer for that. Total of 2 marks there. Right, the last question for question 5 to finish. Isaac is going to sell one of his programs are distributed on a DVD. Give 2 advantages of choosing a programming language that uses a compiler rather than interpreter for a program that will be distributed on a DVD. There's a difference between compilers and interpreters. Compilers creates an executable file. Once you've created that file, you no longer need to use the IDE. You no longer need to see the programming code. You just see the executable file, you can just run that. Whereas with something like Python, which is interpreter based, you still need the IDE to be able to run the program. And it doesn't create an executable file, it just creates, you've just got this code, you can see the code, and you need to have the IDE, you need to have idle, for example, to run the Python code. So my 2 points there, the target computer does not need to have the original compilers. An executable file is created and compiler will optimize the code. And that completes question 5 for 14 marks. Question 6. 2 emerging technologies are DNA computing and quantum computing. Explain one difference between DNA computing and traditional computing. DNA computing uses biochemistry. So to construct an answer here, so DNA uses biomolecular components rather than standard silicon chips. You can also have DNA uses chemical reactions rather than electrical states, ones and zeros, and that completes number 1. Number 2, give the definition of the term superposition in quantum computing. Superposition is the ability of a system to be in multiple states at the same time. Move on. B, ethically, everyone should be able to access the benefit of technology. Give 2 reasons why this might not be possible. This is looking at the digital divide. Some people can't afford it, some people don't have the infrastructure, etc. So we need 2 reasons now, and they need to be sufficiently different. So my first reason is some people simply don't want to use the technology. And my second reason looks at cost. Some people simply cannot afford to use the technology. C, widespread use of computer technology has a negative environmental impact. Discuss the negative environmental impact of using computers and actions that can be taken to reduce it. Now this is a 2-hour exam. It could be worth writing a plan for a 6-mark question rather than going in, unless you've got a really strong idea about what you want to write and how you're going to do it. I would probably plan it out first on some scrap paper and then go and construct my answer rather than just write everything that comes into my head. It is worth doing that because this is 6 marks. I think with 2 hours, you've probably got the time to do that. You need to look at the impacts and you need to look at the actions that can be taken for those impacts. So one impact is there's going to be an environmental cost from the manufacturing process, whether that's mining or that's pollution from the manufacturing process. There is an environmental cost to that. So let's list some more impacts now. So we've also got mineral mining, contaminated ground, and that having an impact on the people who use the water, and also the surrounding environments, that's animals as well, and the environment that has this polluted water in it. We've also got computing devices can often be sent to landfill after they become obsolete, and maybe I could add to that it's polluting the ground, and obviously we're going to run out of landfill spaces. It's not ideal to put rubbish junk into the ground and then bury it in the ground because it simply won't disintegrate. So maybe at least 3 impacts there, and then we'll look at the actions that can be taken to offset those to gain the 6 marks. Some countries require manufacturers to recycle their own waste and can't just any kind of waste, hazardous materials needs to be disposed of properly. We can also research recycling facilities to see if e-waste is acceptable and how it's disposed of. How does that happen? We can also find sellers that exchange old for new and give money off a new device by exchanging and recycling an old one. There's lots of sellers that offer that. We can also find charities that take donations of old devices and find new uses and homes for them. So anything there to kind of the actions to offset some of the problems there. Some of the impacts of electronic devices. Now that completes question 6 for 11 marks, and that completes the whole paper for a total of 80 marks. As always, big thanks for watching. Please like and subscribe, and I'll see you in the next video. Thank you. Bye bye.